Sodium-ion batteries entered the battery world much later than most other chemistries, but they have quickly become far more capable than anyone expected. Tesla has already moved toward adopting its most refined sodium-ion battery technology, known as the Tesla Sodium-ion Battery 4.0. Elon Musk has mentioned many times that Tesla has explored a huge number of battery chemistries over the years, yet only a handful were truly suitable for Tesla's long-term goals. Sodium-ion is one of those rare options that managed to stand out. In the early stages, sodium-ion batteries had extremely low energy density and were basically unusable for electric vehicles, reaching only around 100 watt-hours per kilogram when the bare minimum needed for practical electric cars is 150 watt-hours per kilogram. But Elon Musk and his engineering teams never stopped pushing. They refined the materials again and again, and eventually created a sodium-ion battery with an energy density almost equal to today's lithium iron phosphate cells while also reducing the charging time to only 3 minutes. Oh my goodness, this is the very first time a sodium-ion pack has ever reached this level of performance, and it is something even Elon Musk cannot overlook. Right now, battery production is no longer Tesla's biggest limitation. This is especially true with the 4680 lines ramping up at a stunning pace. However, those powerful and expensive cells are reserved for high-end models like the Tesla Semi and the Cybertruck. With Tesla preparing to release the $26,000 affordable electric car next year, the company needs a battery that is stable, low cost, and much cheaper to produce than traditional lithium iron phosphate cells. Without it, scaling production would be extremely difficult. So the question becomes, will Tesla choose the new sodium-ion battery 4.0 for the affordable model? What makes this chemistry special enough to potentially replace lithium in certain vehicles? And why is it positioned to become the least expensive electric vehicle battery in the entire world? It is not solid-state batteries, and it is not some extreme experimental chemistry that automakers are turning toward as a backup strategy. It is sodium-ion. With lithium prices increasing and supply becoming harder to maintain, sodium-ion technology has quickly become the preferred low-cost alternative, especially for companies that want to build more affordable electric cars. Many battery technologies have appeared beside lithium during the last several years, but sodium-ion has shown the fastest pace of improvement, boosting its energy density by around 40% in only 2 years. That speed is faster than any other mainstream battery technology globally. And the biggest advantage sodium has is something no other chemistry can fully compete with: massive abundance. Sodium exists everywhere in nature, which makes it extremely inexpensive to extract and refine. By the way, if you are enjoying this deep dive and want more detailed videos about Tesla and future battery technologies, make sure to hit that subscribe button right now in your own unique amp drive style, because your support helps us grow faster than ever. Sodium-ion batteries are expected to cost between $40 and $80 per kilowatt-hour, compared to nearly $120 per kilowatt-hour for most lithium-ion packs today. Just from a resource standpoint, sodium is around 500 to 1,000 times more common than lithium in the Earth's crust. Beyond that, obtaining sodium is far less harmful to land and ecosystems than lithium extraction. Even though Elon Musk has recently stated that Tesla's new battery design has removed lithium completely, he also said the overall structure remains similar to lithium-based batteries. Simply put, the Tesla sodium-ion battery 4.0 still uses a cathode, an anode, a separator, and a liquid electrolyte. The main change is that sodium replaces lithium as the charge carrier. Another major advantage is that the cathode and anode in sodium-ion designs can use aluminum for both sides, while lithium-ion batteries must use pricey copper for the anode. Copper is significantly costlier than aluminum. Elon Musk also explained that the production cost of Tesla's new sodium-ion cells is many times lower than that of the 4680 cells. Instead of using expensive and rare materials like nickel, cobalt, lithium, and copper, Tesla's fourth-generation sodium-ion battery uses sodium-based cathodes and relies on very common and eco-friendly materials such as iron, aluminum, and manganese. In performance tests, Tesla's sodium-ion battery reached around 190 watt-hours per kilogram, which is even higher than the 175 watt-hours per kilogram of the leading sodium-ion battery from CATL. There are not many sodium-ion batteries on Earth today that can reach this spec. CATL has said they will reach 200 watt-hours per kilogram soon, but that milestone has not yet been demonstrated publicly. To be honest, 190 watt-hours per kilogram is not an extremely high value when compared to high-end lithium technologies. It is still far below Tesla's 4680 cells. But when compared to lithium iron phosphate batteries, which are widely used in affordable electric cars, Tesla's sodium-ion batteries are not inferior at all. In fact, they are slightly better even before considering their lower cost. With a 62 kilowatt-hour pack, Tesla's sodium-ion battery enables around 300 miles of driving range. Hitting a 300-mile range with a sodium-ion pack has always been a hard challenge. No other sodium-ion battery previously managed to reach that number in a commercial-ready configuration. Elon Musk revealed that recent breakthroughs in battery material engineering have significantly improved the performance of sodium-ion technology, allowing it to overcome its long-standing weakness in energy density. When it comes to charging speed, sodium-ion batteries look very promising. Several experiments have shown that sodium cells can charge and discharge more than 20 times faster than lithium-ion cells. With only a 3-minute charge, Tesla's sodium-ion battery can provide an additional 110 miles of range. Oh my goodness, that alone makes up for the lower energy density. At this level of speed, a Tesla Model Y could potentially charge from empty to full in about 9 minutes. That is nearly identical to the experience of filling up a gasoline vehicle at a fuel station. With sodium-ion batteries, your driving range might be shorter compared to some long-range electric vehicles, but you will never wait long before continuing your trip. This makes the driving experience feel more balanced than owning a long-range electric vehicle that requires 40 or 50 minutes to recharge during road trips. In Tesla's newest demonstrations, the sodium-ion battery 4.0 maintained around 80% of its capacity even after 7,000 to 8,000 cycles, and engineers believe sodium-based cells may eventually reach up to 80,000 cycles under certain conditions. But that is not even the most shocking part. Sodium-ion batteries from Tesla are extremely safe. Tesla performed extreme durability tests, including drilling directly into individual cells and cutting them open. None of the cells showed signs of overheating. This level of safety is mainly due to the inherent chemical stability of sodium-based materials, which makes this technology far more resistant to thermal runaway. Elon Musk said that the sodium-ion line can operate in an incredibly wide temperature range from -40 degrees Celsius to more than 70 degrees Celsius, setting an entirely new standard for temperature tolerance. At -40 degrees Celsius, Tesla's sodium-ion battery still keeps around 90% of its usable capacity. Even when the pack is almost empty, its performance remains stable in freezing weather. When compared to lithium batteries, Tesla's sodium-ion packs show unmatched resistance to overheating, greatly lowering the risk of fire or explosion. Studies indicate that sodium's stable atomic structure makes the battery far less likely to ignite even if short circuits occur. Another major benefit is that sodium is a non-toxic material, so even if the battery becomes damaged, the health risks are low. This eliminates much of the fear people have regarding electric vehicle fires and thick smoke from lithium battery incidents. Sodium-ion batteries also maintain stable performance in cold conditions, which is extremely valuable. Many sodium-ion battery samples have shown the ability to charge from 5% to 80% in around 15 minutes even when temperatures are at -10 degrees Celsius. This could be a major win for people living in cold regions who often hesitate when considering switching to electric cars because lithium batteries lose so much efficiency in winter. Elon Musk almost never talks publicly about the exact cost of Tesla's batteries. Even though the 4680 cell has existed for several years, Tesla still has not revealed its true cost. Based on market data, if sodium-ion batteries reach full-scale production, they could be 30% to 60% cheaper than lithium iron phosphate batteries. The biggest cost savings come from the abundant availability of sodium and the low cost of extraction. Sodium-ion cells also use aluminum instead of copper as the positive current collector, which lowers cost further and reduces supply chain pressure. Replacing lithium with sodium in an entire electric vehicle battery pack could reduce costs by around 30%. A 30% cost drop is massive in any technology industry. In many cases, even a 5% difference can change the entire market landscape. If Tesla's sodium-ion battery 4.0 reaches around $80 per kilowatt-hour while lithium iron phosphate packs remain near $120 per kilowatt-hour, the impact will be enormous. It will be a true game changer. One big question people often ask is why the industry even needs sodium-ion batteries if lithium-ion batteries are so advanced and widely used. The answer is actually very simple. Lithium-ion batteries cannot fully solve all the challenges of electric vehicles, especially now that automakers are racing to build cheaper mass-market cars. Sodium-ion batteries provide relief because they use extremely common materials, which also reduces the risk of supply shortages. This is becoming urgent because global lithium demand is rising so fast that severe lithium shortages could begin as early as 2026, affecting lithium battery production dramatically. Although lithium exists in rocks, clay, and even saltwater, its global reserves are not endless. The extraction process requires a huge amount of energy and land. As global demand increases while natural supply stays limited, lithium prices have soared, earning it the nickname, white gold, of the electric vehicle age. For the electric vehicle industry, sodium-ion batteries offer enormous advantages, especially for Tesla's $26,000 affordable car target. Low cost and independence from lithium allow Tesla to keep pushing toward mass-market electrification. Adding sodium-ion technology to Tesla's supply chain provides long-term stability. This becomes even more important when many experts predict that lithium demand could increase around 500 times over the coming decades. That means battery diversification is no longer optional. It is a survival strategy. One key Tesla supplier, CATL, is preparing to launch its second-generation sodium-ion battery with a target of 200 watt-hours per kilogram. Their current generation sits at around 175 watt-hours per kilogram. At the same time, a former Tesla engineer launched his own startup dedicated to sodium-ion cells. He claims his company's sodium-ion technology will deliver up to 300 miles of driving range, which is one of the boldest claims the sodium-ion world has seen. So can sodium-ion batteries replace lithium batteries? The answer is no, at least not in the short term. Most experts believe sodium-ion and lithium-ion will exist together and complement each other. Sodium-ion batteries are more suitable for medium and low-speed electric vehicles and large energy storage systems. As investment grows and supply chains strengthen, sodium-ion batteries will become a major addition to the energy storage market. They shine in categories where cost, safety, and temperature tolerance matter more than raw energy density. At this point, sodium-ion products will mainly be used in applications that require under 150 watt-hours per kilogram. They will play a major role in reducing pressure on lithium resources. Right now, there are no obvious obstacles blocking large-scale production of sodium-ion batteries. Once mass production begins, their performance is expected to approach lithium-ion levels at the cost of lead-acid batteries. Sodium-ion development is a story of continuous innovation, and eventually, sodium-ion technology will directly compete with lithium-ion for market share. Beyond energy density, sodium batteries today can reach around 5,000 cycles, although that is still below the 8,000 to 10,000 cycles of commercial lithium iron phosphate batteries. Sodium-ion cells need additional testing and refinement before they can fully support massive grid-level energy storage. CATL has also introduced its second-generation Xinjiang battery, which will be installed in 67 vehicles this year from brands such as Zeekr, NIO, and Avatar. This fast-charging battery can provide around 800 kilometers of range and can add over 500 kilometers with just 5 minutes of charging. It even outperforms BYD in charging speed. Some demonstrations showed charging at nearly 1,000 kilowatts, maintaining more than 500 kilowatts even when the battery was more than halfway full. CATL is also investing heavily in battery swapping systems with partners like NEO to help distribute its new battery technologies faster. Today, more than 18 million vehicles using CATL batteries are operating across more than 66 countries, showing how reliable and trusted these technologies already are. With sodium's abundance and high safety, sodium-ion batteries reduce dependence on lithium, helping move the world toward true energy independence. Fast charging has improved dramatically and is no longer the biggest issue. Now the main challenges are infrastructure, supply chains, and cost. Many experts believe sodium-ion batteries could enter mainstream adoption within 2 or 3 years. Lithium-ion still dominates electric vehicles, but the Tesla Model 2, the $26,000 affordable Tesla Elon Musk teased, depends heavily on lowering battery costs. Tesla already uses lithium iron phosphate batteries for budget versions of the Model 3 and Model Y, but even those are not cheap enough for the $26,000 price target. Sodium-ion might be the key to unlocking that price. As Tesla works to make electric vehicles cheaper and more accessible, sodium-ion batteries look increasingly attractive thanks to low cost, reasonable charging speed, and very high safety. They may not outperform lithium-ion in energy density, but they could allow more people to experience Tesla vehicles without stretching their budgets. And if Tesla solves the remaining energy density challenges, producing sodium-ion batteries at the Nevada Gigafactory could become reality sooner than expected. When comparing sodium-ion and lithium-ion batteries, you can clearly see that each one has special advantages. Sodium-ion batteries win in cost, temperature performance, safety, and material abundance. Lithium-ion batteries win in energy density and already established manufacturing ecosystems. As technology evolves, both will likely exist together, offering flexible solutions for many different energy needs. The race between these two technologies shows how fast the world is moving toward cleaner and more efficient battery systems. So if Tesla releases a $26,000 electric vehicle using sodium-ion batteries, would you consider buying it? Thank you so much for watching, and if you enjoyed this breakdown, please press the like button and subscribe for more content about electric vehicles and future battery innovations. Share your thoughts in the comments because we love hearing from you, and do not forget to turn on the notification bell so you never miss our next video. See you again soon.